Okay, good morning. First, I want to have a couple of announcements. Number one is I just post a new assignment on the Zybook, and so you can actually start to work on this. It's basically the chapter 6, even though I haven't completed chapter 6 yet. So I think last time we talked about mainly two things. We talked about the two different type of variable. I'm sorry, it's one is called a field variable. Okay, and also the other one is called the local variables. Okay, the field variables are basically the variable that's defined in the class, but it's outside the methods. So, and the local variable is basically defined only in a method or even in a small block in the method. Okay, so local variable is only visible inside the block. For example, if it declared a variable in the method, then the local variable is only valid in the method. And outside the method, it doesn't exist. So other method or the main method cannot actually see the local variables. But the field variable is actually kind of different. So it's visible to all the methods in the class. Okay. Now, that's basically, it's called the scope of the variable. Okay. Now, we mentioned last time that if you have a field variable which has exactly the same name as a local variable, or on the other way, that you declare a field variable called x, you define x and assign the initial value to x. And then in the method, in the local area, you declare another variable called x. Okay, so that means you have a, say, public class, my class, and I declare a variable, say int x equals 10. And then in a method, I declare a public static, whatever. The method does not return a value. So I say my method 1. So whatever the argument in there, I declare int x, okay? And I assign x equals 20. So based on the Java syntax, if the variable is declared as a local variable and also declared as a field variable, and then inside the method, the local variable will override the field variable. That means the field variable is not accessible inside the method. So everything inside the method, the x is a local variable. It's just this one. But outside this method, x is still the field variable. Okay. Now, a general rule of thumb is if it's possible, try to avoid this kind of situation. So that means you try to avoid to define a field variable and the local variable with the same name. There's no actual advantage for this. The only actual reason you want to do this is to confuse people. So try not to do this. Okay. So I think we actually give you the example about the field variable and the local variable with the same name. It actually causes a lot of confusion because there's a side effect. We mentioned about the side effect for this case, right? The side effect is basically just eventually cause the variable that which has assigned a name that which is not as expected. So try to avoid this kind of situation. And also, I forgot I talked about this or not. We also talk about the, when you use the scanner to import a value. Scanner is a very powerful tool that allow people to, import value from the prompt. So you can actually, the user can type the import value. Okay, this is actually, the way that you actually import the value. The other way you can import the value is by using the assignments, right? You can assign 20 to x. So say x equals 20, then that's another way to import value. But a scanner is very flexible. However, every time you want to use a scanner to import a value, you need to define a scanner object, right? You need to define a scanner object. So now, if you want to do this, then try to avoid to define too many scanner objects. Okay. Now, the best good practice is in one program, you can just create one scanner object and use this one scanner object to import values. It doesn't matter how many values you want to import. You don't have to create different scanner object to import different value. You can use exactly the same scanner object to import many different values. Okay. Now, why is this? Okay, because in Java, when you create any object, it's very costly. Because when you declare, say, something, say, scanner, say, my scan, and I'm going to say new scanner system dot in, right? So that's one way you can actually create a scanner object called a my scanner. And then you can use my scanner, say, my scanner, my scan dot next int. You can actually import an integer value, and you can call it again scanner scan dot next int. So you basically import a next value. So this is just a one scanner object, but you can import many values. Now, if you create too many scanners, now because each time when you call this, statement and create a scanner object, the Java need to reserve a space. Okay, called that space gonna actually, create the object called myScan, which is actually scanner object. So this is gonna take time because when you create the scanner, Java need to reserve the space, memory space, and so this is gonna actually take some time. Now, if you actually create too many scanners, this is gonna actually impact your performance. Okay, impact the performance of the program. So try not to actually create as many scanner object as possible. Now, the best approach is to create just one scanner object and use the scanner object throughout the whole program. Okay. Now, one approach is this. Okay. Let me show you one of the program. Let's say, okay. So I'm going to use the program called use the figure actually 6.8.1, which is in the Zybook. Let's see. Here's the one I want to show you. Okay, let me actually do this. I'm going to stop the presenting here. I'm going to present another one. Okay. Now, here's a REPEL. I use the REPEL IT. So this is actually the same example we used in the Zybooks. So I create a class called calculate the pizza calorie. Okay, so we try to, when you eat, you always try to calculate the calories, how much actual food you just ate, right? Now, so in this example, we create two methods. One is called get pizza calorie, and another method is called calculate circle area. Why? Because a pizza is always not necessary, but most of pizza is actually it's a circle, right? So in order to calculate the calories, so then you need to figure out how big is the pizza. So basically, you need to calculate the area of that pizza. And then in this method, we provide some variable called a calorie per square inch. Okay, each square inch, there's a 16.7 calories. I don't know if 16.7 is big or not. But normally, you're not going to eat a pizza of 1 square inch, right? Typically, you're going to eat at least a 10, I'm not sure, maybe 5 square inches. Is 5 square inch pizza a big slice? I don't know. So that's, each square inch, it's 16.7 calories. So for a pizza, so in order to calculate how much calories that the particular pizza contains, you need to calculate the area, right? In terms of square inch. So then you're typically going to measure the diameter or radius of the circle, right? So that's why we need the two methods. Okay, the first method, so you need to calculate the area based on the diameters. Okay, and then the second method, you basically calculate the calories based on the area. So here in the main method, okay, I'm gonna create a scanner object. Okay, it's called SCNR, and then I'm gonna call the method get pizza calories, and pass this scan object SCNR. Okay, pass this as a parameter, as an argument. Okay, so when I call get pizza calorie, so then I go to the get pizza calorie. That's the method defined here. Okay, so when I call this, okay, now when I call get pizza calorie, I pass the scan object, okay, which is SCNR, and then in this get pizza calorie, I'm gonna import the value, which is the pizza's diameter. Okay, when I import the value, I use scanner object SCNR and I just call next double. Okay, so it's not an integer. They show as a double because they want to actually import as the diameter doesn't have to be like a 1 inch, 2 inch, 3 inch. When you make a pizza, the diameter could be like a 10.5 inches, right? It could be a real number. It's not necessarily an integer. So then I import, use the scanner object to import a double and assign this double value to the pizza diameter. So that's the value you just typed. Okay. So then the pizza diameter, with the pizza diameter, you can calculate the area of the pizza. So then how to calculate the area of the pizza? You call another method called the calc circle area. Now, when you calculate the circle area, you provide a pizza diameter, right? So then where's the circle area? The calc circle area is here. So this is a method called inside the method called get pizza calorie. So the get pizza calorie is going to call another method, calculate circle area. So you provide a pizza diameter. So then that's the parameter. And then inside this implementation, so I can actually, when they provide a circle diameter, in order to calculate the area, I need to actually get the radius. The radius is half of the circle, right? Half of the diameter, because when you have a pizza, it's a circle. The diameter is from one side to the other. The radius is from the center to the side. So it's half of the diameter. So I calculate the pizza circle radius. And then here is the method I use to calculate the area of the circle. It's the pi, which is 3.1415. So that's the value of pi. Okay. And then pi times the r square, the square of the radius. Okay. So it's a pi times, is it right? If you know the radius of the circle, if the radius is, you can the area is always pi times the square of the radius, right? So you calculate the area, and then you return the area. So return as a double. So this method calculate circle area going to return the area. So the area is returned by calling, okay, calculate the circle area. So that's the area of the circle with the pizza diameter. So the pizza diameter is the diameter of the pizza, and the calculate the circle area going to return the area of that pizza. Okay, so that's the area per square inch, actually square inches. And then to calculate the total calorie, you need to calculate the area times the calories per square inch. So if the area is 20 square inch, then it's 20 times 16.7, right? So that's a total calorie. And then you return the total calorie for this method. So this method can eventually return the total calorie. Okay. And then you call it twice, and you can call it third time, right? I can just put it here and return and call it again. So each time when I call get pizza calorie, it's gonna prompt for you to enter the diameter of the pizza, and then it will eventually calculate the total pizza calorie, because that get pizza calorie gonna return the total calorie. Okay, so pizza has the calorie numbers. Okay, now let's actually compile this. Calculate pizza. Okay. Then I call this method using Java, compile use Java C, and call the method use Java. And I type the name of the file, which is calculate the pizza calorie. So when I actually first call, and I actually print out this one, okay. So when I actually call get pizza calorie, so then it will actually call the get pizza calorie, and eventually going to print out enter pizza diameter inches. So this is what is printed out. And then you need to actually type your value, and this value is going to be assigned to pizza diameter, right? So I'm going to say, what about 10 inch? So the diameter is 10 inch. Well, how big is 10 inch? About this, right? It's not a big pizza. Big pizza, yeah, let's say 10 inch pizza. How many actually calories? I hit the enter. So this is going to eventually, I enter the 10 inch, okay? I enter 10 inch. So you're going to calculate, so here I'm going to call another method called the calculate circle area with pizza diameter, which is 10 inch. So then I call this with a 10 inch here. And so the radius is going to be 10 divided by 2. It's a 5 inches, right? 5 times 5 times the pi. So that's the area, and the return area, that's the area. And then times the 16.7. So that's the total carry, and return the total carry and print it here. Okay. So this pizza has 1,311 calories. I don't know how many calories need to get for each day, you know. But let's say the second time when I call the next one, okay, the next actually print LN statement and I call the get pizza carry again, you're gonna prompt for another output, okay, and then I put the 18. That's 18-inch diameter. The pizza has 4,249 calories. Let's say 22. Okay, that's it. Because I only call 3 times, right? I only call 3 times. Now in this case, we only created one scanner object. Okay, that's a SCNR. And I pass this scanner object each time when I call get pizza carry. Okay, so only one scanner object is created. Okay, and I called multiple times. Each time I call get pizza carry, I use the same scanner object, which is declared in the main method, right? So that's an approach. Now the other approach I can do is I can say, well, can I comment this one out? Okay, and then I call the scanner object inside the pizza method, the pizza calories. I call this scanner object over here, right? And then, since I call the scanner object inside the method, I don't have to pass this scanner object because it does not exist anymore, right? It's not actually declared. SCNI is not declared in the main method. So when I call the method, I don't have to pass the scanner object as a parameter. So in this case, I can eliminate all this. Instead of pass the scanner object, I create the scanner object inside. Okay. So scanner SCNA, each time when I call get pizza carry, I create the scanner object. I import the value. And next time when I call get pizza carries, I'm gonna call scanner object, create the scanner object, and call it. Okay, let's see. Okay, let's say I just compile it again. And 1,311, 18, same value, 22, same value. So I don't see much difference. They're basically the same. Now, the results are the same, but the computer actually operates slightly differently. In the previous scenario, I create a scanner object in the main method. And each time I call get pizza carry, I pass this object to the method. So I only create one method and pass two different. Each time when I call it, I pass this object. So only one object is created. But this time, I don't actually pass the object anymore. So inside the method definition, I create a scanner object. So that means each time when I call get pizza carry, I create an object. And then I call another get pizza carry, I call an object. So each time when I call, it will create a separate object. Okay. That's the difference. Technically, this one is worse. The previous one is better. Okay. So that's why we should not create the scanner over here. You should use create the scanner object in the main method and pass the scanner object over here. Okay, and pass the scanner object over here. SCNR. See the difference here? Okay, that's the how you're gonna. That basically tells you how you're gonna use the scanner. Okay, because scanner gonna create it as an object. Try to, if you can reduce the number of scanner object, do it. Okay, let me actually switch back to the PowerPoint again. Now, the next thing we're going to talk about is called oversized arrays. Okay, we mentioned that when you actually try to use the array, you have to declare an array, right? Like if you want to declare an array of integer, you can certainly do so. So let's say int, it's array, and I say my array equals new int 20. Okay, so I declare an array of 20 elements. This array contains integer elements, right? So I can just say my array 0 equals 1, my array 1 equals 2, or whatever. You can continue. Or the other way you can declare array is you declare array, say my array 2. And I actually initialize the array elements over here if it's not so big. So I can say 0, 1, 7, 2, 4, 6, 7, 8. So I have actually initialized the array into how many elements? 1, 2, 3, 4, 5, 6, 7. 7 elements. So this basically declare array 2, my array 2, with 7 elements. Okay, I can do that. Now, in Java, if you declare array, you have to specify how many array elements for this actually array. For this array. Now you can either define using this approach and create, tells people how many array elements. So you put the 20, that means 20 elements. Or you can define the array, by initialized array, and this way you actually declare the array and you provide array element, number of array elements implicitly, because it depends on how many elements in here, because then you're going to define the number of array elements. So in this case, the array elements is 7. But the bottom line is, when you declare the array, when you actually assign the array elements, you have to make sure you explicitly specify how many array elements for this one. Okay. Now, what about if I say, I want to use an array, but at this moment, I don't know how many elements I actually need for this array. One example is if I want to declare an array of string, and I want to actually put the student name here. So basically, I want to declare an array called a student. And so then I don't know how many students I want to actually define, and for in this array. So for example, I want to define a student in this class. How many students do you want to actually define during the definition of the array? You want to say 20 students or 30 students? I don't know, because I don't know how many students in this class. Okay. Now in this case, that's the oversized array. So an oversized array is an array where number of elements used is less than or equal to the memory allocated. Okay. Um, why you want to do this? If you know how many elements for this array, of course you should tell people, I want to declare an array of 100 elements. But in reality, the reality is many times you don't know. Okay, like the number of students in the class. This semester I have 20 students, and next semester I only have 15 students. Or even in the same semester, when I actually declare an array of 20 students, and then actually more than 20 students actually sign up for the class, then in this case you cannot accommodate all the students, because you only declare an array of 20 elements, but you now have 22 students. That's a problem. Okay. Now, if you declare as 20 students, array of 20 students, but your actual number of students is only 15, that's okay. Maybe 5 spaces is wasted, but that's okay, right? It's still actually doable. So this gave you some kind of idea that when you deal with array without knowing how many elements you're going to actually need, you can actually set up a value, the maximum value you expect the array could be. Okay, then you can use this maximum value, and then you can actually manipulate the array with the actual number of indexes. So since the number of elements used in the oversized array is usually less than the array length, the separate integer variable is used to keep track of how many array elements are currently used. Oversized array are used for when number of elements stored in the array is not known in advance, or when the number of elements stored in the array varies over time, just like the number of students in a class. So initially, 18 students signed up for the class, and the 3 students dropped the class after a week, and the 2 more students added into the class. So the number of elements actually is changing. So in that case, how can we deal with that? Then you need actually 3 elements. One, you need to declare an array variable, and then you need to define the maximum number you could actually accommodate for this array. So let's say I don't know how many students in the class, but I set up a number which says the number of students are allowed in this class is 20. Okay, 20 is the maximum allowed for this array, for this class. And then when I actually do manipulate the student in the class, the number of class actually doesn't have to be 20. It could be 12, could be 15, could be 18, but never actually more than 20. You never actually allowed actually more than 20 students in to to enter the class, because your array is declared as maximum of 20 elements. Okay, so typically what you do is you're going to declare a constant variable. So when you use the final, you declare the constant variable. I'm going to say int maximum max num, and I put 20. And then when you declare the student array student, I put the maximum none. Sorry, It's not so clear, but that's maximum none. It's declared over here. Okay. And also I'm going to define the actual number. So I say current size, the current size of the class. So the current size I can initially set to 0, and later I can change the current size to 1, to 2, to 20. Oh, I'm sorry, it cannot be more than 20. So to 15, to 12. So you can always change the current size to manipulate the student array, but never actually, reach the 20. Okay. So typically you use actually a maximum number and a current size to manipulate this. Okay. Now you can actually check the Zybooks for various different examples, but I don't want to show each of the example in the class. So first, when you actually deal with oversized arrays, say if you want to use the array, but I don't know the array size, so then you need to figure out what could be the maximum number what's the maximum number of elements you want this array to be, and then set up the maximum number, and then set up another number, which is the current one number. So that means that number is actually the current size of the array. Even though there's a difficulty in this situation, but you have to do this. Okay. Now, when you set up the size, you don't want to actually set up a number too small. So if the array is too small, the program will fail because if the number of elements exceed the maximum number. So if the program will fail when the number of required elements exceeds the number of allocated elements. This is going to fail. Or you don't want to actually put the maximum number too big, okay? Because if you say, well, I want to declare an array of students, the maximum number of students in the class is 100. Now, in reality, your classroom never have actually, your classroom, never cannot accommodate 100 students, okay? Your classroom only have like 22 computers. So you only can accommodate the maximum of 22 students. So in that case, you can set up a maximum number of 22 instead of 100. Because when you actually reserve a space for 100, you're gonna waste a lot of computer memory space. Okay. So that's why choosing the maximum number is very important. Okay. If your number is too small, it say, oh, the class size, the maximum number of students is 20. Now, what about if I have 21 students? So you cannot, accept all the students. You have to allow only 20 students to be in the class. But that's probably gonna waste of resource because your lab has 22, right? So that's why choosing the number is very important. So this is how the Java actually deal with. So in practice, oversized array typically use 3 variables: the array reference, the current size, and the constant for the array capacity. Array reference is the array variable, like a student. Okay, that's array reference. And then the current size and the capacity. The array capacity is the maximum number of elements you are allowed for this array. This array capacity is the number that the Java can allocate the computer memory. So that's why this is actually very important. Yeah. Not too big, not too small. Okay. But you actually need to do the practice in the Zybook to understand how you're going to manipulate this array. Okay. Now, 6.11 basically using references in methods. Okay. Arrays can be used in methods, just like int and double variables. Okay. However, an array is stored in memory differently than variables of primitive data types like int or double. Remember what we talked about the last time. So when you perform the array operation, it's not the same as the operation for the primitive variables like a double or int. Okay, let me actually emphasize this again. Let's say if I have an integer a and a b, and I have an integer array actually of integer. Okay, I declare array. Let me see. Okay, now I allocate the c, initialize the value of c to 1, 2, 10, 5, 6. Okay, brace. So 1, 2, 3, 4, 5, 5 elements. And I also declare array of d. I'm gonna say d new. Let's say int. Let's say 5. Now, if a is 20, and then I say b equals a. So now, when I say a equals 20, the Java are gonna actually allocate a memory space for a. Okay. Actually, when you declare the array a as a as an integer, Java gonna allocate the space for an integer size for the integer. Now, when I assign 20 to a, basically I copy 20 to a, right? Now, when I assign a to b, so say b equals a, so that means assign the value of a to b. So when I declare a and b, Java also going to reserve space for b, reserve space for a. When I assign 20 to a, then 20 is copied to a, right? And then when I assign b equals a, so that means I'm going to actually assign the value of b to assign the value of a to b. So then the value of a going to be copied to b. Now both a and b has its own dedicated space. When you actually do the copy, you copy the value to b. Okay. Now maybe I could continue with this coding. So if I say a equals 30 after actually assign the b equals a, then the value of a going to be overwritten by 30, right? And the value of b is still 20 because b and a has stored in a different location. So even though I override the value of a from 20 to 30, and I don't, this doesn't change the value of b. Now, the array is actually different. Okay. Let's say when I actually declare two arrays C and D. Okay. So then maybe actually I'm actually running out of space. I need actually more space to do this. So let's see. Let me actually open a Word document. Okay. So when Java actually declare an array C, so Java basically reserve a space. Okay. But this C is not integer. It's an array of integer type. Okay. And then Java also reserve a D. Okay. it's also an array of integer. Now, if I initialize the value of C with, initialize the array integer array C with 1 to 10, 5, and 6, what Java gonna do is Java gonna say, okay, I'm gonna allocate the memory space for 5 elements, because initially it's actually initialized with 5 elements. So I'm gonna allocate the memory space with 5 elements. Okay, and each element is an integer type, and I assign 1 to the first element, assign 2, assign 10, assign 5, and assign 6. Now, once Java allocates the memory space for these 5 elements, and then it's going to be stored somewhere, right? So let's say it's stored in the memory location, memory address 1000. So this is actually the memory address of the first integer in the array, and this is actually the object which contains the array of C. So then when I actually create the object which contains the array of 5 array elements, 1, 2, 10, 5, 6, and stored in the memory, and the first memory address of the first element is 1000. Okay, and then what Java gonna do is Java gonna actually assign the value 1000 in the array variable C. Okay, because this, sorry, every time I touch something, you're gonna actually just make the word disappear. So when I actually do this, then when I actually initialize this value to C, then it actually assigned the reference value, the memory address 1000 to in the reference of C. Okay, and this basically means I point C to this object, because C contains the memory address for this object. Okay, so that's complete the initialization. Okay, so I declare the variable C and I create the object during the initialization, and which contains the initial values for each element, and then I point C to that object. Okay, that's the first. Now when I declare the variable D, because D is actually declared as an array of integer, but I know D has 5 elements. Okay, but I haven't assigned a value for D yet. Okay, now what about if I say, yeah, what about D equals C? So C is an element, right? C is an array. D is also an array with the same size. Now when I assign C to D, so that I say D equals C, what does Java do? What does Java do? You think that the Java actually say, oh, I'm going to copy C to D, so I can actually say, create an object, because C has actually 5 elements, so D I'm going to create object of 5 elements, and then I copy each individual 1 to here, 1 to 10, and 5, 6, and I point the D to this one here, and this object could be in a different location, like 2000. Okay, so I put a 2000. Okay, so what's the meaning of this D equals C?
Isn't it changing the reference to where it is in memory?
Yes, you got the point. So what the Java Java does is not to create another object and copy the whole things over here. So Java does not do this. Okay. What Java do is much easier. When I actually do this copy, Java only does something called a reference copy. You know, the value stored in the array C, this value stored in the array C is actually the memory address of the object that C is pointing to. So now this value 1000 is a memory address, and we call it reference value. Okay, it's a reference value. So when you make a copy, say D equals C, that means I copy value of C to D. I actually copy this reference value to D. Okay, so I actually copied this one, the reference value from C to D. Now what does that mean? So D is an array of integer, and D's reference value is 1000, which is the same as C. That means D is actually pointing to the same object that the C points to. That's the meaning of this copy. So, and this is called reference copy. Okay, that's what the Java does. Okay, now understand this, then you can talk about when I actually define a method, and when I pass the parameter array as a parameter in the method, when you pass the array of as a parameter in a method, so when you actually call the array method with array parameter argument, you are not actually copy each of the individual value. You basically copy the reference. Okay, keep that in mind. Now, back to this topic. The reference copy is many times is also called a shallow copy. Okay. Now, there's another type of copy. Well, it's just like I say. You actually say, I have another actually declare another integer, array of integer. I call it ABCDE, and E is a new and int 5. So what about if I want to create E and I say, well, I don't want to do the reference copy. So I want to create E, and I also want to completely copy every single element and create a new object and copy every single element from C to D. So I copy every single element 1, 2, 10, 5, 6. And I just actually stored this new object somewhere, definitely in a different memory location, right? Because this memory location 1000 has been used. So I store in another memory location, say 2001. And I actually assign 2001 in this reference and I point E to here. Now, if I actually create another array and I copy every single element, and that copy is called a deep copy. Now, how can I do the deep copy? Definitely, I cannot do the deep copy by calling this E equals C. No, that doesn't do the job. This only do the reference copy. How can you do the deep copy? You have to do the loop and copy each individual element. Okay, so that means I have to do the for loop, say, what are you going to do? For int I equals 0, I less than 5, plus I, and then I'm going to say E I equals CI, right? That way, I copy each individual, say C0 is 1, C1 is 2, and then I create each time when I create each array element for E, I actually copy this one by one. Okay. Not just,
Would it be possible to use I as less than E dot length minus 1 instead of I is less than 5?
oh yeah, you can do this because when you declare E, because you already specified the number, so you can just say E dot length, right? Yeah, you can do that. It's the same. It's a 5. Yeah, that's good. Actually, that's better because when you put the 5, what about if I change the size? Then it's not the same number anymore. So if you use E dot length, if I change the value here, then E dot length, the value of E dot length has been changed as well. Yeah, that's better. But what I'm saying that when you do the deep copy, you have to copy each individual element, not just use the variable name, the array variable name. So that this only gonna do the reference copy. Now back to the method. Okay. So now when you actually use the define method, and the method has the references. Okay, method has array parameters. Keep that in mind. This is only gonna do the only do the reference copy. Let me actually give you an example here. Let me actually erase that. Okay, here we go. So let's say we have array method. Okay, so let's say I define a method. The method does not return a value. And I'm going to say method 1. Okay, I use array as a parameter. I'm going to say A. Okay. So what I do is I'm going to say now in the main method, okay, in the main method, so I have to squeeze the main method over here. This is actually inside the main method, okay? Suppose inside the main method. Okay, so then I declare an array x, and I'm going to say x1, 2, 3, 4. This is always the quickest way to initialize the array element. Okay. And then I call method 1, and I pass x. What about this? So I declare array, and I initialize the value to 1, 2, 3, 4. So x0 equals 1, x1 equals 2, x2 equals 3, x3 equals 4. And then I actually use this x, pass this x to method 1. I call method 1. Okay, so x is going to be the argument x is going to be passed to a, right? Now here, when you pass x to a, remember that's a reference pass. That's a reference pass, okay? What does that mean is in the method 1, I'm going to actually declare an array a, okay? Now, when you declare array x here in the main method, so x is going to be declared as array elements, array actual variable. And when I initialize the array variable to 1, 2, 3, 4, Java going to basically create an object, right? 1, 2, 3, 4. And then I can actually refer this point x to this object using the reference here. Okay. The reference is the memory address of this object. So I just call it the reference. Okay. Now, when I pass x to a, that's a reference passing. So that means I can only pass this reference value of a to x to a. So if x is reference value is 90, that 90 is passed to a. So what does that mean is I'm going to point a to the same object that the x point to. So that's a reference passing, okay? Unlike these variable, like an integer or double, when I actually pass the x to a, if x is not an array, if x is just an integer, and a is just an integer. So basically, both x and a are going to be created as a reserve a different memory location, and the value of a going to be copied to a. So value of x can be copied to a. So a and x going to be stored in a separate memory location. But here it's a reference call. So both a and x going to point to the same object. Now what does that mean? So if I actually inside the method, I change the value of a, say, okay, now when I pass it, a point to the object x point to. So a0 equals 1, a1 equals 2, right? a0 equals 1, a1 equals 2. But inside the method, if I change the value of a0, okay, so a0 equals 2, so that means I actually going to change the value here, right? To 2. And at a1 equals 3, I'm going to change a1, the second element, to 3. Any questions on this? Now, what's the side effect? Now, so that means even though A is an array declared in the method, the change of A can have an impact on the value of X. Because when I refer X here, if I say print, please actually display the value of X. So what is the value of X1, X0? After actually method call. Because X points to the same object that A points to. Now, A, because A actually changed the value of object, right? A0 becomes 2 now. A1 becomes 3 now. So when I refer to X0, X0 going to be 2 as well, right? It's not a 1 anymore. And the X1 going to be 3. And X2 is still 3. X3 is still 4 because I haven't changed that value inside the method yet. So that means anything changed in this method going to have an impact on the original array X. That's the kind of side effect for the reference passing. That's called a reference passing. Okay. Reference passing actually only actually pass the reference value. So you don't actually create any new object. So reference passed, so then that means that both actually array variable going to point to the same object. So it doesn't matter whether this is in the method. This is actually in the main method. This is in the method 1. Okay. Okay, I'm gonna skip next one. Also, it's the same kind of idea. When I define a method, say a public static method. Oh, I'm sorry. Method name is called, I call my method. Okay. My method may actually pass the x. Okay. So then, if I declare an integer, array integer, and I say a is array integer. Okay. Now, so a is declared inside the method, my method. Okay. It's an array. Now I'm gonna say a equals x. X is actually now a. Oh, I'm sorry. I cannot use that. I should have to say a0 equals x, right? A0 equals x. Let's erase that one. Okay. Because a is an array, so a0 equals x. A1 equals x times x squared. Let's see, what's the next one? I'm running out of space here. So I'm going to say A2 equals x times x times x. Okay. And then continue with the method. I'm going to say return A. Closing the bracket. So when I return A is declared as a variable. So this method can return a variable, an array. So I'm going to actually put the int square bracket. So this method can return an array. Now, just keep that in mind. When I return A, which is an array, and in the static method, I return int, it's going to be returned as reference. Okay. So array reference is returned from the method. So that means if I actually declared array, so when I say in the main method, okay, say main method. In the main method, I just call, say, int x equals 2. Okay, and then I call the method. And I also create another integer, array of integer y. Okay, new int 3. And then I'm going to say y equals my method x. When I call my method x, and I pass the value of x to here, right? And so this value 2 will be passed to x. So x is 2. So then this is actually 2 will be assigned to a0. So a0 is 2. A1 is 2 times 2, 4. A2 is 2 times 2 times 2 is 8. So basically, the value of a variable actually a is array, and which has 3 values: 2, 4, 8. And this a going to point to here. When I return a, okay, so when I call method, it's going to return a. So the reference of a will be copied to y. So that means when y declared as an array in the main method. When I return A, the method return A, so the reference of A will be copied to Y. So Y going to point to the same object A is pointing to. So that's a reference passing, okay? So when I return variable, it's also a reference passing. So Java normally in a copy or method actual reference, Java always use the reference copy. Okay. Now why is this? You may ask. Why Java doesn't make like a deep copy? So every time when you call a method, it's not just a copy of the reference. It's just copied at the actual elements. Why is this? Because this going to save a lot of space, right? If we are talking about an array of like 1 million elements. So when you make a function call, if it's a reference call, it's so simple. I just copy the reference value. So, and then the new actually array variable going to point to the same object, and which contains 1 billion elements. This will be very quick. Think about if I make a deep copy, then I have to copy each individual element. Now, if I copy 1 million individual elements, this is going to be very painful process because it's going to take a long time. It's not going to work. So that's the reason why Java actually only use the reference copy for array, because you don't know how big the array could be. Okay. And also, you're going to save a lot of space. If you do make a deep copy, then if you copy 3 times, Java going to create 3 different objects. Each object going to take the same amount of space. That's a lot of work, and it's not desirable. So that's why when you make a function call, or when you make like a array assignment, like a A's array, B's array, say A equals B, and it's just copy the reference, not the whole object. So when you make that reference call, you basically point to the array available to the same object, the other actually variable point to. So that's basically but that's basically the meaning of the reference call. Okay. So I think that's pretty much all I want to talk about for today. So and also I'm pretty much done with the chapter 6, the method. Okay, the Java method. So chapter 7, chapter 7, going to be the class and object. Now we are going to really touch the real topics for Java, because Java is regarded as object-oriented programming language. So what does the object mean? So that means Java going to create a various different object for the same class. Okay, that's something we're going to talk about next time. Okay, I think that's pretty much all for today. So you have any questions? Please check the Blackboard, actually the design book, because I have actually assigned you another work, the chapter 6 work. So if you have any questions, please actually ask me and let me know as soon as possible. Okay.
Yeah, Professor, do you have a minute at the end of the class?
Okay. Yeah. I have to actually stop the recording, and yeah.
Yeah.